Now, as we look at this, we're going to find amounts, final amounts, in word problems on exponential growth. Here, the rate will be something greater than, when we add this together, greater than 100%, and then we're going to times it by time. Or decay, where you're going to lose a certain amount, so this rate could have been negative in a sense, but we're going to look for its positive value as we take it away from 100. So this is in a sense 1, the whole, this is our rate. So let's look at this in some detail. And I was getting a little confused, and by the way, this is the formula for simple interest. Principal times the rate times the time. And this is the rate for simple interest, but over a period of years where the time is going to be as an exponent. And then the other formula I mentioned was future amount is equal to P, and then in parentheses we had the 1 plus the rate over the period of time it's compounded in 1 year times the number of times we compound it times the number of years. So this is an exponent. Now for anything that has an annual rate, it's going to be compounded annually. Then n is 1 here, and n is 1 here, so you have this formula. Okay, and there's some other formulas that I was thinking of, but didn't really apply here. So let's look at this. A certain forest covers this much. So we know this is going to be our P here. Now suppose that each year this area is decreased by 7%. What will be the area after 15 years? You're going to use a calculator, that's up over on the top there, and round your answer to the nearest square kilometer. Now, let's look at what's going to be inside the parenthesis here. Now, since this is a decrease, it's going to be 1 minus this 7% here. So when we do this calculation, what we end up in the parenthesis is 0.93. Now raise to the 15th power, and then in a sense we're timing it by the 3700. So again, you could put all of this into your calculator, and this is what they're showing down in this particular step here. Now they're showing it that after 2 years, after 3 years, after 4 years. But if you want to have it for 15 years, to shorten this process, that's what you do. Alright, let's take a look at the next part of this. So I kept my printing on it, but I moved it up. So 2 years, 3 years, but we want 15 years. So our exponent here is our time value. That's going to be 15. So we'll raise it up a little bit more. So there is the answer. Put that in your calculator just to verify. So when you round off to the nearest whole, since this is 7, the 5 becomes a 6. And there's your answer. Okay, I know the other part was a tad confusing, and I was looking for a little bit more of a formula for these things, but I see they weren't using these formulas as such, although some examples might use it. Hopefully this will be helpful. And I should add that this being 0.93 is less than 100%, so that was decrease. if for some reason the forested area were to increase by 7%, in that parenthesis would have been 1.07, again indicating it's increasing by a certain percent, and then you still have time as your exponent. So this was a decrease, the others are an increase. That'll wrap it up.